Okay, so it really is not super difficult. We just need to make sure that we cover a few things. So again, we're going to talk about the mean value theorem, and we are focusing on integrals now, even though we've talked about derivatives before. And for the MVT for integrals, a lot of the concepts and conditions still hold true, meaning our function has to be continuous on a closed interval. Okay, and there will be at least one point, I like to call it C, not X star. It's the same thing. It's just a dummy variable that we're using. Okay, dummy. Such that the following will hold true. Okay, so we have the integral from a to b of f of x dx. So what does this right here represent? The integral, you guys just told me before. In words, the area under the curve. So we're saying that the area under the curve is equal to, now how did we calculate this for Riemann sum? You told me just 3 minutes ago. Okay, width times height. Okay, what is f of x then? What does that represent? Yeah, this is my height. This is my y value. So we could say either f of x sub star or f of c, it doesn't matter, we're plugging in that value, so this is going to be my height. And then this right here, you told me, is my width. And b minus a represents the furthest right x value to the closest x value, right? So this would be our width. Okay, so this is really nothing new. Right now we're just putting it together. We're saying that the area under the curve would be equal to the height times the width, or the width times the height. It's the same thing. Okay, so what we're saying is, if we had, and I gave the example of a fish tank where the surface has not been bumped, this would be completely flat and would be nice and easy for us to find the area under the curve. But then along comes your little brother, your little sister, and they're messing around and they bump the fish tank, and then you've got these huge waves. We still want to be able to calculate the area under the curve, this right here, okay, as a rectangle, because it would be easier for us to do so. But what we're looking at is this wave right here. If I were looking at the area under the curve, this portion that we see that is grayed in, if I knew what this function was, this curve, if I knew what the equation was and I wanted to integrate it, would this portion be included? This right here? No, it would not. But then doesn't it look visually like this area right here would be equivalent to this area right here? So if that wave was equalized, meaning I let the fish tank water settle down and then I could calculate the area using the rectangle, this would be the same. Ideally, that's what we're looking at. Conceptually, this is what we're saying, is that we want this area right here as a rectangle to be represented by this, and they would be equal. So this is why, if I know what this function is right here, I could integrate it from a to b, and I could set that equal to the height times the width. And what they're saying is there is some unknown value, and we're calling it either x star or c. Okay, it's just a value in between a and b, where there's going to be a point where the area above in the curve and the area below, meaning this and this, would be equal to each other. And that's what we're trying to identify. Where does that happen? So there could be more than one value of c where you have equal heights below the rectangle and above the rectangle representing the wave or the curve. Okay, but a lot of times when we give you a smaller segment from a to b, smaller interval, and we're just looking at, is there some value where this gets cut off, saying that this area here below this portion of the rectangle but above the curve, and then here below this curve but above the rectangle would be equal. So if I did, let's say, pull the curve straight, I could find the area under the curve just by using a rectangle. Okay, so they're looking at where does that happen. There's this breaking point here. Okay, so here's where you would see the question. It would say find all values of c, same as x star. okay, in the stated interval. So it is important that you take a look at the interval once you find your answer. You need to make sure that all the value or values that you calculate fall in that interval. If they don't, you just don't include those in your answer. Okay, so let's say you get 3 values and only 2 fall in the interval, you disclude the other value. So it says that we want to satisfy the mean value theorem for integrals and then explain what these numbers represent. I'm not going to ask that you draw the diagram because we typically don't ask you for that. I'm going to show you what the diagram looks like and how it is similar to something like this, because this is what we're looking for. So what is the process? First of all, you need to make sure that this function in this interval satisfy the portion of the mean value theorem that says the function is continuous and you have a closed interval. So the first thing you want to look at is the function continuous? Okay, x squared, is that function continuous? Yes, it's a parabola. And then, is there a closed interval?
Yes.
Okay, so here's the one thing that we talked about with respect to continuity for any function when we were taking the derivative. So I want everybody just to look up here. You don't have to write anything. I'll go back to the page in just a second. But if I gave you the function 1 over x minus 5 and I said to you, is this function continuous? No. Why? Not a whole. A vertical asymptote. What would make it a whole? Yeah, you'd have to have an x minus 5 on the top and then something else in the bottom with the x minus 5, okay? But basically you know it's not continuous. Now, if I said to you, is the function continuous over this interval? Yes. Okay. So there's a difference, and we did talk about this when we were dealing with derivatives. So you need to look at the whole picture, whereas the case that we are given here, even if we didn't look at the whole picture, meaning I didn't look at the interval, x squared is it's not always going to be a polynomial. Okay, so you have to consider both pieces. Everybody good? Okay. So continuous, closed interval, check. So now this is what we're going to do. We are going to use this setup, meaning we have the function, we have our interval, and we can figure out what the width is. We want to find at what height does this occur. Where is this going to happen where the area under the curve is equal to the width, the area if we had just a solid rectangle. You guys with me? So we're using this here. So we're going to say the integral from 0 to 2 of x squared dx, okay, I'm just using the equation from above, is equal to, and then it's going to be the height times the width. And that height, we are using x star, I'm going to use c, okay, f of c, okay, times, what's b minus a? 2. I'm just going to write 2 minus 0 just for now, but it's just 2. Okay, all I did was plug into the equation. Does everyone understand where everything came from? Okay, this right here represents my unknown height, f of c. If I said to you, given this information, evaluate f of 5, what does that mean, f of 5? Think algebra. F of 5. Just say what? Okay, so given the point, or the x coordinate 5, what is our y? How would I find that here in this case? Plug 5, if the x value was 5, plug 5 into x squared. But we don't know what that x value is, do we? It's c. So where do I put c? Yes, in x squared. You put it, so now what's it going to be? I don't know what the number is, it's c squared. Does everyone understand where I'm getting c squared from? So if this function was, I'm just making it up, 2x minus 1, it would be 2c minus 1. Because we're trying to find that c value. Where is this going to occur? On this graph, this would represent my c. This is the same thing as c. Okay, let's integrate. What is the integral of x squared? 1/3 x to the third to be evaluated from 0 to 2 is equal to, you guys told me this is going to be 2c squared. Does everyone understand where 2c squared came from? Okay? So now let's evaluate. When I plug in 2, I end up with 8/3. What happens when I plug in 0? It's just 0. So do I have to write it down? 2 cubed is 8 times 1/3 is 8/3. And this is equal to 2c squared. Okay. So now I need to solve for c. What do I do first?
Multiply 8/3 by 1/2.
Sure. So this is what, I'm going to go up here. This is 4/3 is equal to c squared. Okay, now what? Okay, so I'm taking the square root. C is equal to 2 over the square root of 3. Is that it? Do you have to rationalize? This is calculus. No. Welcome to calculus. Yes. I know. Big people math. We get to skip steps. Okay, I'm missing something though. What am I missing?
Plus or minus.
Ah, that's right. When you take the square root. Oh, nuts. You get 2 answers, plus or minus. Come on, guys. Negative 2 over the square root of 3. Now, it doesn't matter that someone's going to say, what are you going to say? It's not in the interval, but still, you need to include the answer because what if it was? Then you'd miss out on an answer. Okay, this value, just so you know, is 1.155. How do I know that? Because it's on my paper, and I calculated it yesterday. No, I don't have a calculator for a brain. I don't. Okay, so this is 1.155 approximately, but I'm telling you this, why? So we can make sure that it's on the interval. It is on the interval. This would not be included. Okay, is everybody with me so far? Now, if I asked you for the height, remember, this represents my x value. I would have to, if I asked you for the height, you would have to turn around and plug it into x squared. Okay, but this is the c value where this occurs, meaning on the interval from 0 to 2, at approximately, let's say 1.2, so I can get a better idea of where it is, the height would be equalized, and I'm going to show you the graph. This is what I'm talking about. So this right here is the graph of x squared from 0 to 2. You guys with me so far? It's the right side of a parabola. Should make sense. And what we're saying is from 0 to 2, there's some given value c where the area above would be equal to this area below. See, this is like open, because if I wanted the area under the curve, isn't it this right here? But if I made a rectangle from 0 to 2, this should be equal to this, meaning if I calculated it using width times height, I should get close to the same thing. So what I was saying before is, this is my c value, or my x star value. If I wanted the height, I would plug 2 over the square root of 3 into x squared and provide the height. I'm just asking you, at what c value does this occur? You gave it to me. It's 2 over the square root of 3. Okay, does everyone understand what I'm talking about? Are you sure? Literally, it's just the algebra, but you have to know what the equation is. This. Okay, so this is important. Now, here's another question that I have for you. If I wanted you to solve this equation for the height, what would you do? I just want you, just the equation, just this, all generic. How do you solve? Meaning I want to isolate h, or f of c. Yes, sir?
You just solve it and then not plug in the equation. You wouldn't plug in.
Let's think even more simplistic. I know what you're saying. You're given this.
Get to the other side.
Get what to the other side?
B minus A, the width.
How do I do that? Divide. That's what I'm saying. Like, think even more. Like, don't even worry about, there's no equation, there's no function, no nothing. This is just the general formula. If I wanted to solve for the height, which is represented by this notation here, you move this over here by dividing, right? Or multiplying by the reciprocal, 1 over b minus a. I'm asking you because there's another formula that is known as the average value function, and we're going to talk about its application. Bless you. Okay? Now, again, your function must be continuous on a closed interval. The average value, or mean value, MVT, right? Mean value, okay, is defined as the following. This is the same formula, it's just manipulated. So we're saying that the average value of the function is equal to 1 over b minus a times the integral of the function from a to b. All I did was move the width over, I'm solving for the height. That's what the average value is. It is the height. This is what we're solving for. So if I ask you for the average value, I'm asking you to solve for the height. So all of these are the same. This is the graph from above. This is the fish tank example that I gave after your sibling bumped it. This is before or after you let it settle.
Sick waves.
So I'm asking you here, if I gave you a choice, you're just looking at those two, which one of these would you rather calculate the area for, the left or the right?
All right.
I would definitely, it's easier. Look at all this craziness. I don't even have a function. I have to try to create some kind of weird shit. No, I'm going to wait. I'll go get some lunch. I'll come back. It'll settle down. Okay, so this is what we're going to use. Does anyone have any questions? I'm going to show you what we're using it for in just a second. Next page.